Hi, I'm Rosenberg, and today I'll be talking about the paper Towards Collective Superintelligence, Amplifying Group IQ Using Conversational Swarms. And so as background, this relates to the field of collective intelligence, also referred to as wisdom of crowds. The idea is that large groups can be smarter than individual members. The concept goes back to 1906. Sir Francis Galton ran a famous experiment where he asked 800 villagers to guess the weight of an ox. As individuals, they were widely variant, but when he took the statistical mean, it was actually quite accurate. The other interesting thing is that today's methods really haven't changed very much since 1906. It's really about aggregating data from isolated individuals through polls and surveys and prediction markets, where the quote crowd really only exists in a database. But it works. It amplifies intelligence. It gives a boost, and it has uses, but they're narrow uses, things like forecasting and estimation, where you can collect a set of data and aggregate, but lots of problems in the world don't fall into those categories, and that's an open issue, which is the reason to push for something better. Collective superintelligence would be a system that would enable large groups not just to aggregate opinions, but to deliberate complex problems and converge on solutions, and the goal would be to capture not just the answer, but the reasons behind the answer. And it turns out that Mother Nature points us in the right direction. It's called swarm intelligence, and it's the reason why birds flock and fish school and bees swarm. They can make decisions together in real time that are significantly smarter, aggregating data across large sets of perspectives to solve all the issues that they need to navigate their lives. And so the first push in this direction was a technology called Artificial Swarm Intelligence, or Swarm AI, developed in 2015 and has been researched quite extensively over the last 8-9 years. And it emulates swarms by enabling groups to form real-time systems and converge on answers in real time, pushing and pulling on each other instead of aggregating data offline. And it works. Swarm AI has been shown to outperform statistical aggregation with significantly more accurate predictions and forecasts and estimations. And I won't go into that, but the paper cites lots of previous studies that demonstrate this. But this type of method has the same problem as statistical aggregation, which is we don't get a sense of the reason why, and we're also confined to easily defined problems, not open-ended problems. So this leads us to Conversational Swarm Intelligence in 2023 called CSI, and the goal here is to combine the collective intelligence benefits of Swarm AI with the flexibility and informational content contained in real-time conversational deliberations, so we can tackle open-ended questions and get the justifications and amplify collective intelligence. So conversational deliberation has all kinds of benefits. Enables groups to debate complex issues, express and support resistance for ideas, generate ideas and alternatives, build on the ideas of others, and converge on solutions. But there's a very significant limitation of real-time conversations, which is that conversations don't scale beyond about 4 to 7 people, which puts collective intelligence out of reach. Why don't conversations scale? Because as the groups get bigger, the airtime per person decreases, and the turn-taking dynamics fall apart, with each person having to wait longer and longer to respond to anything that's said. And so by 10 to 12 people, conversations become a sequence of monologues. So how can you enable 100 people or 1,000 people or 1,000,000 people to hold a conversation? Well, it turns out that Mother Nature shows us a way. Fish schools, this school has thousands of fish, and they can make decisions very, very rapidly, and they function so well together. Biologists refer to them as a superorganism. They do this by actually they have a special organ on the sides of their body called a lateral line that detects vibrations in the water. And so each fish basically is communicating with a small set of neighbors. They can detect the speed and direction of other fish. And so if a fish sees a predator, that small group will get that information. And the magic happens because all of these little subgroups overlap. So every fish is in a different little subgroup. They all overlap, and information can quickly propagate across the whole swarm, and they can make these rapid decisions, and they get the benefits of real-time collective intelligence. And so the question then is, well, how can we humans form a swarm intelligence? Well, the method that's used in conversational swarm intelligence is to first divide the population into a group of small subgroups, each that's small enough for thoughtful deliberation. And then the natural step would be, let's make the subgroups overlap. Unfortunately, we humans can't do that. If you can hear two conversations at once, you immediately get confused. It's actually called the cocktail party problem. If you're in a cocktail party, if you start paying attention to another group near you, you'll get confused, and our brains actually are very good at blocking out that other group. And so how do we solve this and make the groups overlap? Well, this technology solves it by using AI agents. We create an AI agent. We put one in every one of the rooms. Those agents are designed to observe the small conversation in its subgroup and then share that conversational insights with other subgroups. And then the agents in those other groups express those insights. And so now you have a full conversation that's networked together with insights passing between all the groups, and yet each small subgroup can hold a thoughtful conversation among a small set. It's called Conversational Swarm Intelligence, and it works. And so this little animation shows a real-time system of about 100 people, AI agents passing information between all these small groups of 5 people, and they can converge on answers. And a number of studies have been done that shows that this works. And so the current study, we built the technology of conversational swarm intelligence into a platform called Thinkscape. It allows groups of any size to hold text conversations while AI agents pass information and weave all the groups together. And we use this platform to do IQ testing, where we wanted to bring in groups of people and 35 people, groups of 35 people. We administered a standard IQ test. The system divided this group of 35 into 7 groups of 5, wove them together, asked them to solve IQ questions, and we compared to a traditional wisdom of crowd where they took the tests on a survey, and we just took the most popular answers. And we used the Raven's Advanced Progressive Matrices IQ test. It's a graphical, groups of 35. We looked at the average individual, we looked at the wisdom of crowd, and we looked at this conversational swarm intelligence. And the average individual scored 150th percentile, which is what you would expect if you take a group of random people. Wisdom of crowd, when we took we took the most popular answers from groups of 35, boost intelligence, got it up to the 84th percentile, 115 IQ, and when they worked together as a conversational swarm, boosted up to the 97th percentile, 128 IQ. And so you can actually see average individual, wisdom of crowd, conversational swarm intelligence was significantly better, performed the statistical analysis and saw that the amplification of intelligence was statistically significant. And in fact, the interesting thing is that not a single individual in the groups of 35 matched or beat the IQ level of the conversational swarm of 128. And so conclusions, conversational swarm intelligence as a viable method for large-scale conversations. It could work for any size group, 100 people, 1,000 people, etc. Could support other modalities, not just text chat, but voice chat, video chat, VR chat. We saw intelligence amplification observed. Basically, it's combining the interactive benefits of small-scale deliberation with the aggregation benefits of collective intelligence. And for future work, we're looking at running tests with larger groups, 500, 1,000, many thousand, and also looking at more efficient and effective methods for insight passing. And so conversational swarm intelligence, a useful form of communication that combines the benefits of small-scale deliberation with large-scale collective intelligence. Thanks.